Every day, millions of dollars are expended on engine downtime, costly repairs, poor fuel economy, and pollution control. The reason? Inefficient combustion. There is no engine, gasoline or diesel, that can burn all of the available fuel at the time that it can do the most good. That portion of fuel which remains unburned causes a variety of problems. Unburned fuel leaves behind a gummy residue called varnish. Varnish builds up on engine components, coating surfaces and plugging oil passages and filters. Varnish also prohibits proper engine lubrication by encouraging oil contamination. Partially burned fuel in the combustion chamber also collects and accumulates on the coolest parts of the chamber as carbon. Carbon forms a hardened, abrasive deposit on your engine. Just a 1/4 inch of carbon buildup acts like 3 inches of metal insulation, producing heat and poor performance. A combination of carbon and varnish in your engine reduces the efficiency and useful life of your engine. Besides wasting fuel, inefficient combustion produces exhaust emissions which are harmful to the environment. Varnish, hard carbon, high exhaust emissions, corrosion, rust, poor fuels, and water and fuel. They cost us all money. Some cause engine damage, and some are the results of inefficient combustion. For years, the fuel additive industry has attempted to remedy these problems with a variety of approaches. They fall into 3 main categories: cleaning treatments, surfactants, and octane or cetane improvers. Let's quickly go through each one and look at their strengths and weaknesses. Cleaning treatments contain alcohols and other solvents that remove varnish and loosen carbon from internal engine components. These solvents also absorb small amounts of water from the fuel system. Unfortunately, they may also change the fuel specifications, which could change engine performance. Surfactants increase compression by dispersing lubricants onto the walls of the cylinder. In theory, this creates better compression, which should increase power output. But in practice, these same lubricants are suspended onto delicate ignition and injection components and often lead to fouling. Surfactants, like cleaning treatments, are also highly expensive. Octane or cetane improvers can improve engine performance, but fuel efficiency and maintenance of the engine are not usually affected. In fact, by changing fuel specifications, octane or cetane improvers can actually create a false sense of security and damage engines. This change in fuel specifications can also lead to warranty issues, and like other fuel additives, they are highly expensive. A remedy? Hardly. These types of additives are neither practical nor cost-effective in preventing the formation of combustion-related deposits or emissions. And they do nothing to get at the root of the problem: inefficient combustion. Yet there is a way to combat the problem. It's a specially formulated combustion catalyst and comprehensive fuel treatment called XFT, or extreme fuel treatment. This combustion catalyst, XFT, does not change fuel specifications. It simply increases combustion efficiency. The result? More of the available fuel is burned when the piston is near optimum position, and less unburned fuel is left behind to contaminate internal components. In other words, we burn more of the available BTUs of the fuel. Fuel economy and air quality are improved and carbon buildup is reduced. Since its development, the XFT formulation has over 2.5 billion aggregate miles of operation in internal combustion engines, from small light-duty engines to large 25,000 horsepower diesel generator engine. This equates to over 65 million hours of successful engine operation. Here's how XFT works. Engine manufacturers design engines to run most efficiently at optimum compression pressures and temperatures. These pressures and temperatures are represented on this curve, which shows the ideal designed engine pressure cycle. Unfortunately, in practice, nothing works ideally. This green curve shows an actual engine cycle. It differs from the ideal cycle for several reasons. The main reason has to do with fuel. Today's blended fuels burn slowly enough to lower engine efficiency. XFT reduces this problem by reducing ignition delay, which helps existing fuels ignite faster. Test results show that by igniting fuel slightly faster, XFT alters the normal engine cycle curve, bringing it much closer to the ideal curve. How does XFT promote faster ignition? Normally, when the fuel in the combustion chamber ignites, the flame advances in a single avalanching front, like this. Researchers have determined that with the addition of XFT, the fuel burns more uniformly from many different fronts at once. Microscopic soluble sandwich molecules contained in XFT absorb radiant energy from the ignition center and ignite at several points ahead of the initial flame front. This results in multiple flame fronts, which work together to burn the fuel more efficiently. The results have been documented. XFT increased the efficiency of the engine pressure cycle. More fuel is burned and more energy is released when it can do the most good at the top of the compression cycle. Numerous independent studies further document the effects of the catalyst relative to combustion temperatures and NOx levels. These studies identify average reductions in NOx due to decreased lingering combustion temperatures and accelerated combustion reaction with the addition of XFT. The XFT formula also helps prevent pings, backfiring, and ignition delays. A research paper presented at the Society of Automotive Engineering Conference, referencing the effects of an organometallic-based fuel catalyst on diesel fleets, explains XFT's possible mode of operation and summarizes the results of EPA and long-term fuel maintenance studies. These studies included emission evaluations utilizing EPA test procedures which were conducted at Olson Laboratories in California. The evaluations followed standard emission testing methods and utilized the Highway Fuel Economy Test and the Federal Test Procedure, which is a stop-and-go driving cycle. The results showed emission savings with the catalyst. The XFT formulation also has been subjected to the Society of Automotive Engineers evaluations for fuel economy and drivability. Other tests conducted, both at the university level and by independent laboratories, also show significant average fuel economy improvements in gasoline applications and in diesel applications. In addition to these tests, the manufacturers of XFT are conducting long-term maintenance studies with industry leaders to demonstrate the product's effectiveness. Numerous mass carbon balance tests have been run using EPA procedures, and these tests show improvement in fuel economy and emissions reductions. One of these studies was recently completed with a Detroit Diesel 6V71 engine. This engine underwent approximately 500,000 miles of total operation. During the last 20,000 miles, it was run with catalyst-treated fuel. Pistons and liners show a marked reduction in carbon buildup. The carbon that remains is soft enough to be wiped away with a shop cloth. The head areas are surprisingly clean. There is virtually no carbon buildup on the compression surfaces. Similarly, the valve stems show little or no carbon buildup, resulting in the elimination of valve torching. Another study was conducted with this Caterpillar 3406 engine used in the over-the-road trucking industry. It had accumulated 786,000 miles of operation using the XFT formulation. The carbon liner ridge shows a soft carbon residue, and piston crowns show very little carbon buildup. This 25,000 horsepower MAN BW compressor represents the before and after pictures of carbon reduction on pistons with treatment. The smokestacks also showed a remarkable reduction in smoke after using fuel treated with XFT. This HD 785 5 Komatsu haul truck with 15,000 hours of operation using the catalyst shows carbon buildup in the pistons and crowns is virtually non-existent. The cylinders wipe clean enough to reveal the manufacturer's part numbers. This lack of carbon is not uncommon in engines run with XFT. Maintenance studies have also been conducted in the marine industry, as well as farming, construction, over-the-road trucks, light trucks, and passenger cars. These and other studies conducted worldwide have documented the effectiveness of XFT. It is the only product on the market today that effectively addresses the problem of inefficient combustion. Time after time, it has proven to reduce engine maintenance expenses and increase fuel economy and reduce harmful emissions on new or used engines. One mining industry leader who currently uses XFT is saving over $2 million a year in fuel costs alone. Additional savings are also generated through reduced maintenance. Similar savings can be demonstrated in your fleet through the use of sophisticated exhaust gas analysis equipment at your site. By processing the results of the exhaust gas analysis through universally accepted carbon balance procedures, XFT has demonstrated a typical return of more than 400% on existing customers' investments. The XFT formula is unique and is very concentrated. A 55-gallon drum of XFT treats 550,000 gallons of fuel. Not only does XFT have a proven burn rate modifier, or catalyst, but the formula also has detergents, which help clean engines, lubricants that lube injectors and other parts of the engine, stabilizers to stabilize fuel for long periods of time, polymerization retardants that stop solid formations in the fuels, corrosion and rust inhibitors that help stop buildup in engines and tanks, and demulsifiers that control water that can harm injectors and valves. The XFT product adds up to the most comprehensive and efficient fuel catalyst on the market today. Every day, millions of dollars are expended on engine downtime, costly repairs, poor fuel economy, and environmental issues. But now, thousands of those dollars can be saved through the use of XFT, and you and your company can enjoy these benefits. XFT, trusted because it works.